Good morning, calculus. We are going to start differential equations, and as you can see, we're at the end of our pad. Oh dear. I have to find some more paper. It'll be all right. So, differential equations. We did some differential equations earlier on. In the school year, these are a little bit different. They're going to deal with integration. If you get one of these on the AP test free response, you get super happy. A differential equation is usually worth about 6 points, and the first 3 to 4 are pretty easy to get. So we do like to see these, although sometimes they can get a little tricky. We'll start off easy and then we'll get a little bit harder. I'm probably going to break this up into 2 videos because we've got 9 examples to go through today. So that way you can decide whether you want to do it in one day or if you want to break it up into 2. All right, so the first thing. If you are given y prime, go ahead and change that to dy dx or dy dt. Okay, you want to change that because what we're going to do is we're going to separate our variables. We want our x's to go with our x's and our y's to go with our y's, or t's if that's the matter, and go through and be able to solve each side. So let's go ahead and write down our steps first. After we write down our steps, we'll go ahead and get started with practicing. Now, remember, when you're writing down the steps, they might not make any sense until we actually get started, but we'll refer back to our steps as we're doing them. So for number 1, the first thing you want to do is separate your variables. Okay, so that means that the y's will go with dy, and the x's will go with dx. Okay, now you want to leave integers and negative values on the side with the x. Leave integers and negatives on the x side. And again, remember, if this doesn't make sense, it will once we get started and start working through. Okay? Now, separation of variables. On an AP test, that's going to be worth a point. If you can separate the variables successfully, they're happy. Yay, point for you. Moving on to number 2. You want to integrate both sides. And then you want to do a plus c on the x side only. We'll talk about why it's only on the x side in a little bit. But integrating both sides, that gives you 1 to 2 points on an AP test. And then the plus c, that gives you a point. Just by putting in plus c, a whole point. So you're already at 3 to 4 points right there with steps 1, 2, and 3. With steps 1 and 2. Now, step 3. You get 2 directions that you can go for step 3. Okay? If they give you an initial condition, and we'll talk about what that means. It means that they're just going to give you a function and its value. So if they give you an initial condition, you're going to plug it in, solve for c, and then replace c and solve for y. Okay? Now, if they don't give you an initial condition, no initial condition, then you just want to solve for y. Okay, so we're going to look at examples that deal with all of these things. Okay? So let's go ahead and get started with example 1. All right, so example 1, I'm going to give you y prime plus 2x over y is equal to 0. Now, I'm going to do 2 steps at one time. So up here at the beginning, it said if given y prime, change it to a dy dx. I'm going to go ahead and change that to a dy dx. At the same time, I'm going to move this on to the other side of the equal sign. So I'm going to subtract it over. So I've got dy dx on one side and then my variables on another. So I'm going to rewrite y prime as dy dx. Then I'm going to move this to the other side of the equals, which I have to do by changing its sign. So I subtract it over to the other side. Now I can do my step 1, which is to separate my variables. The y has got to go with the dy, the x has got to go with the dx. So essentially you're cross multiplying at this point. So y over here is going to multiply with dy, so I get y dy. Dx is going to multiply with the negative 2x, so I get negative 2x dx. Okay. Now, I forgot to write up here that you're also given that y of 1 is equal to negative 1. We're not using that yet, but it is an initial condition, so we'll get to it. All right, so now that we've separated our variables, we've done number 1. Okay, number 1, separate the variables. Y go with dy, got it. X's go with dx, got it. Okay, leave integers and negatives on the x side. So this negative and this 2 are going to stay over here on the x side. I mean, of course, you could always divide by negative 2 and have y over negative 2. Just makes life a little bit harder. It's not that you couldn't do it. It's just the math gets a little bit more involved. It's way easier if you leave it over on the x side, I've found, in my opinion. So, step 2 says integrate both sides. We're going to integrate both sides. The integration of y is y squared over 2. And then you get your equal sign. And remember, when you're integrating, the dy's and the dx's, they go away, so you're done. You integrate negative 2x, so that's negative 2x squared over 2, where those would cancel. And you're going to put in your plus c on the side with the x. Okay? Now, we set up here, put the plus c on the x side, but only the x side. And the reason you only have to put it on the x side is because if you had a plus c over here and a plus c over here, those are just numbers. It's just any old constant. So if you had like plus 2 over here and plus 3 over here, you would combine those as like terms, and they would just become yet another constant. So we just call it plus c on one side, takes care of plus c's on both. So we end up with y squared over 2 is equal to a negative x squared plus c. Okay, so that's our equation. Now, we come back to our given. Y of 1 is equal to negative 1. This right here is your x number. This right here is your y number. So we're going to plug it into the equation so that we can solve for what c is. So negative 1 squared over 2, okay, equals a negative, your x is 1 squared plus c. So we get 1/2 equals a negative 1 plus c. When you add 1, you find out that 3 over 2 is equal to c. Okay, 3 over 2 is equal to c. All right, now, the directions said, if your initial condition, plug in, solve for c, which we just did. Now we need to replace c and solve for y. So what we have to do is we have to take this c and plug it into the equation that we just did the substitution for. So we end up with y squared over 2 is equal to negative x squared plus 3 over 2. Now, they say solve for y. So to solve for y, I've got to multiply by a 2. So y squared is equal to negative 2x squared plus 6 over 2, which is just really 3. To get y all by itself, you want to square root both sides. Now, when you square root, you're going to end up with a plus or minus. And I'm going to write it kind of lightly because we're going to talk about whether it's a plus or a minus. Negative 2x squared plus 3. Now, the plus or minus here in these square roots are going to be determined by what was given to you. So since y of 1 was equal to -1, our y is going to be negative. If this had been like a positive, then this would be a positive. If they didn't give you any given or initial condition, then you would have the plus or minus. Since they gave us an initial condition and our initial condition is negative, our answer is going to be negative. So this right here is our final answer for the equation up here. Okay? This right here is our differential equation. So that's example 1. Let's take a look at example 2. All right, example 2, y prime minus x squared y is equal to 0. And I'm not going to give you an initial condition for this one. So we're going to start off just like we did last time. Okay, we're going to change this y prime into a dy dx. We're going to move this to the other side of the equal sign by adding it over. So we get dy dx is equal to a positive x squared y. Now, I need to separate my variables. So I'm going to go ahead and do it in 2 steps. Eventually, you're probably just going to do it in 1. If you notice, you're going to multiply by dx and you're going to divide by y. Like I said, I'll do it in 2 steps. If I multiply by dx, I get dy is equal to x squared y dx. And then I want to divide both sides by y. So I end up with dy over y is equal to x squared dx. So I've gone ahead and I've solved or separated my variables. So my y is on the side with the dy, my x is on the side with the dx. Okay, so again, remember, that's your first point. You've separated the variables. All right, your next step is to go ahead and integrate. Okay, now when you integrate 1 over y, or 1 over u, or 1 over x, or 1 over anything, that's the ln, so we can't forget ln. So this one's going to be ln y equals x cubed over 3 plus c. Remember, the plus c goes on the side with the x. Okay. Now, if we look back at our steps, okay, we integrated both sides, we did plus c on the x side. Well, now, I did not give you an initial condition, which means we need to solve for y. Now, had I given you an initial condition, we would plug it in, solve for c, replace c, and then solve for y. So, we're going to do no initial condition, we're going to solve for y. Now, this one's interesting, because how do you solve for y when y is connected to the ln? You might have to watch this one twice, but once you get it and once you see it, it's going to be the same every time we've got this thing happening. So you're going to be okay once you get through it. First time, kind of tricky, and you got to maybe watch it again to find out what happens. All right, so ln. ln is the same as log base e. So log base e of y equals x cubed over 3 plus c. Now, over to the side, let's remember our log rule. Okay? If you had log base b of x is equal to y, remember our log loop? We said b raised to the y equals x. Okay? We're going to do this log rule with this right here. Here's our log loop. Here's the e. We're going to raise it to all of this stuff, and then we're going to set it equal to that y. So e raised to the x cubed over 3 plus c equals y. Okay. Now, another little thing. Let's think about our exponent rules. If I had x cubed times x squared, I would add those exponents. So x cubed times x squared is x to the 3 plus 2, or x to the 5th. So think about this going backwards. If I had x to the 5th, I could break that up into x to the 3 plus 2, which would break it up into x cubed times x squared. All right, so now let's look over here at this. We've got e to the x cubed plus 3 plus c. So I'm going to break that up into e to the x cubed over 3 times e to the c is equal to y. Okay, so I just did my exponent rules backwards to break it up. Now, why am I doing this? I'm doing this to make it a simpler equation, okay? This is confusing. I don't know what this c is. Plugging things in would be kind of tricky. We don't know how to answer. Like if I gave you ln of 5, you don't know the number of that, so it would be hard to find the c. This just makes life a little bit easier. Now, we do one more step. E to the x cubed over 3. We don't know what that is because we don't know what x is. But e to the c. Remember, e is just a number. Number like 2.7. Blah, 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 blah. It's just like pi. So this is 2.7 raised to some constant. So it's like 2.7 raised to the 5. If I turn on a calculator, and let's say I put in e raised to the 6. It's just some number. Okay, if I put in e raised to the 2, it's just a number. Okay, remember, e raised to the 1, 2.7, blah, 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 blah. So this is just a number. Okay, so let's write that down, just a number. There's no variable in it. Now, how does calculus deal with that? It makes this a big C. Now, if we were together, I don't know, for whatever reason, students like to kind of laugh at big C, but all of a sudden we're going to have a big C in front. I'm going to change and make this y equals. It'll be big C e to the x cubed over 3. Okay? Y is equal to big C e to the x cubed over 3. Now this is our final answer. Okay? Now, I know, you're like, big C, where did big C come from? Well, big C, not to be confused with this C that we put on here, is going to be e raised to the C. And when you have this e and the ln in calculus, we know that big C in front is coming from this right here. We don't know what the value is, we don't know what the constant is, but it is just a constant. Okay, it is just a number. So we just put big C. Now later on in the day, we will solve for that big C, so you'll kind of get an idea of what the answer is. Okay? All right, so let's take a look at number 3. Like I said, watch that one again if you need to see it, or like we're going to see it more often, so you'll see it one more time. All right, dy dt, minus 9t squared e to the negative y is equal to 0. So this is number 3. So this time we're dealing with t's instead of x's, but we still have a y. The first thing we want to do is we want to get the dy dt on one side and then all that other stuff on the other side. So dy dt is over here, and the 9t squared e to the negative y is on the right-hand side. Now, when I multiply over, dt will be over here. I can just go ahead and do that. dt. And I want to divide this to get it on over to the other side. So divide by e to the negative y. Okay, that cancels it out over here. Now, e to the negative y, well, that's just going to be e to the y. I could bring that to the top. I bring it to the top and I don't have a negative exponent anymore. So I have e to the y dy is equal to 9t squared dt. And I've gone ahead and I've solved the problem. Now, let's integrate both sides. The integration of e to the y is just going to be e to the y. The integration of 9t squared is 9t cubed over 3. Don't forget your plus c. Now, we will reduce that 9t cubed over 3 to be 3t cubed plus c. Okay? Now, if I didn't give you an initial condition, we would have to go ahead and solve for y, which is going to be a little interesting, but I'll show you what we have to do. But I am going to give you an initial condition here. We'll still have to solve for y, but we can solve for c in the meantime. Y of 1 is equal to ln of 2. You might be thinking, well, I don't know the value of ln2, but don't worry. Things work out well when we're working out with these ln's and e's. So just plug it in and see what happens. So this is your t, that's your y. So you have e to the ln of 2 equals 3 times 1 cubed plus c. Now, remember, e to the ln of 2, the e and the ln, remember a long time ago, it just cancels out, and it's just equal to 2. 3 times 1 cubed is 3, so you're going to find out that c is equal to negative 1. Now, we want to take this c and plug it into the original equation that we were plugging in and substituting in. So we get e to the y is equal to 3t cubed minus 1. Okay, so I just took this equation right here and I put a minus 1 in right there. Now we're back to solving for y. Well, how do you get that y out of the exponent? Well, the only way I know how to get that y out of the exponent is log or ln. So I'm going to do an ln in front of the e. Well, I can't just put an ln on one side. I got to put an ln on the other side as well. Now, this allows me to pull that exponent to the front. Remember your exponent rules for log land material. So you get y, ln of e, is equal to the ln of your 3t cubed minus 1. Don't forget those absolute values, because remember, you can't have ln to a negative number. Okay? The reason we can't is because if we remember and we look at that graph of ln x, x's are not negative. Okay? Ooh, hard to see. There we go. So you don't have any negative x's when you're doing the graph of ln x. So that's why the absolute value. Now, what is ln e? Remember, ln e is just 1. So that's going to go away, and you end up with y is equal to the ln of 3t cubed minus 1. Now, had we not been able to solve for the c, this would have just been y is equal to ln, the absolute value of 3t cubed plus c. We would have been able to stop at that and not have to worry about it. Now, I know we didn't see a big C, but we're going to get another big C coming up. Oh, in example 5, so we'll get there. This has already been 22 minutes, so we'll go ahead and pause and stop right here at number 3. I'll go ahead and pick up 4, 5, 6, 7, 8, and 9 on the next video.